told you about two lines cut by a transversal. Now we're going to say that those two lines that are cut by a transversal are parallel. Okay, and we kind of previewed that yesterday. Do you guys remember what we'd said with the parallel lines cut by transversal? A lot of those angles were going to be congruent, right? So we have these theorems. It says the corresponding angles theorem says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So it means like those two angles right there are the same. Could we have other ones? Yeah, we could have like these two are the same, right? These two are the same. I shouldn't use the same markings. I'm using different colors, but not the same. So like those two are the same. Does that make sense? Do you guys get it? And then those last ones are the same. Okay, I'm not going to mark it on all of these. I'm just going to mark a couple of them, okay? So alternate interior angle theorem. So the alternate interior angles theorem says if two parallel lines are cut by transversal, then alternate interior angles are congruent. So this angle and this angle are the same. Same with the ones on the other side, right? So this angle and this angle are the same. Does that make sense? Okay, so the way I told you yesterday to think about it is a lot of times when you have parallel lines cut by transversal, you'll have an obtuse angle and an acute angle formed. Okay, so all the obtuse angles are going to be equal. All of the acute angles are going to be equal. Now question, will I always have an obtuse and an acute formed? I don't know. Is there any way to not have an obtuse and an acute formed? Come on, guys, use your thinking skills. Yeah.
The line goes straight.
Yeah, so she's saying the line goes straight. When you say that, are you saying like this?
Yes.
So you have 90 degrees and 90 degrees. Does that make sense? In that case, all of them are congruent. Okay, so we don't have to worry about obtuse and acute because every single angle would be 90 degrees then. All right, so the next one. So it says same side interior angles, or like I said, sometimes I call them consecutive interior angles. So this theorem says if two parallel lines are cut by transversal, consecutive interior angles are not congruent, they're supplementary. Okay, so those are the angles that are like here and here. So these will add to 180. Okay, and the same thing happens with the angles that are over here on the left side too. So like this angle and this angle, those also add to 180. Does that make sense? All right, and then the last one is alternate exterior angles. So alternate exterior angles are also congruent. So those are going to be the ones that are on the outside of the parallel lines and on opposite sides of the transversal. So those two are congruent, and then these two are congruent as well. Okay, so remember alternate means opposite sides of the transversal, exterior means outside of parallel lines, interior means inside parallel lines. Do you guys remember all these terms from yesterday? You feel pretty good with them? Okay. So number one, so it says if you're given that lines P and Q are parallel, explain why the measure of angle 3 plus measure of angle 8 equals 180. So this is kind of like a paragraph proof. Okay, I don't have my statements and reasons set up, but I'm just going to explain why this is true. Okay, all of you can do this. Colin, do you need notes? All right, so take me through this. What do we think? How are 3 and 8? Are those special angles? Do they have names? We don't know the names for those, right? But let's start with maybe 3. And let's mark some things. So 3 has to be the same as what angle?
1.
1 by vertical angles. You could do that, right?
3 is also the same as 7.
3 is also the same as 7. Good. Do you remember what those are called, Maya? Starts with a C. Corresponding angles. So 3 and 7 are the same. Well, 7 and 5 are also the same, right? So all of those angles are the same. So what about 8? Well, what's 8 the same as? 8 is the same as 6 by vertical angles. And it's also the same as 4 by corresponding, and it's also the same as 2 by another vertical angle. Okay, so obviously, since, like, for instance, 7 and 8 are supplementary, they're a linear pair, and they have the same markings as, like, 3 and 8, then we can say those other ones are supplementary. Okay, we want to say this is in as few steps as possible, though. So we marked all that up. But we don't want to mark everything. So that's okay if you have it marked. But let's try to do the least number possible here. So how about if I skip down from 3 to 7? So I could say that angle 3 is congruent to angle 7. Why? Because they're corresponding angles. So I say, by the corresponding angles theorem. We abbreviate a lot of things in geometry. We get tired of writing everything out sometimes. All right, in other words, measure of angle 3 is equal to measure of angle 7, right? Why is that? Do you guys remember that one? How can I go from congruent to equal? Definition of congruence. Okay, but we also know that measure of angle 7 plus measure of angle 8 equals 180. So how do I know 7 and 8 have to add up to be 180? By the definition of, yeah. So they're supplementary, they add up to 180. And then once we have that, can we get to the point where we say measure of angle 3 plus measure of angle 8 equals 180? How can I do that? I just substitute it right in there, right? By substitution. Okay, done. We have it. Okay, I didn't necessarily put it in the whole statements and reason things, but I listed out the reasons why that's true. Okay, now if I was using nice long sentences and using periods and capital letters and so on, that would be called a paragraph proof. So I just listed out why it was true. All right, so number 2. So a pair of parallel lines is cut by a transversal. Use the properties of parallel lines to find the value of x. What is the measure of angle 1? So when I was in geometry, I always marked everything up to start with. So I would always be like, okay, my acute angle here is the same as this acute angle, which is the same as this acute angle, which is the same as this acute angle. Does it make sense? So I have an equation already. I know that 3/4 x minus 5 has to equal what? 3/4. It equals the measure of angle 1. Now, that's not 1 degree. Now, be careful, because I do that sometimes, and that's why I left this on here. I wanted you guys to see that that's like the measure of angle 1. It's naming that angle as angle 1. But what is 3/4 x minus 5 equal to? It's not equal to 1 necessarily. It's equal to the measure of angle 1. It's equal to what number? 70, right? So we're going to say equals 70. And then we solve it out. So I'm going to add the 5 over, so I get 3/4 x equals 75. And some of you have your fraction phobia. You get so scared when you see this. You bust out your calculators. You change it to 0.75. You don't have to. Yeah? 70 because it's over here. So 3/4 x minus 5 equals 70. So don't bust out your calculator. Don't change it to decimals. You guys are smarter than that. If I divide by 3/4, it's the same as multiplying by 4 over 3. So I'm going to multiply by 4 over 3 on both sides. When I do, I get x equals, and I have 75 times 4 divided by 3. I could multiply 75 times 4. I don't want to do that, though. You could. 75 times 4 is like doubled and doubled again. 75 times 2 times 2. How can I reduce? Yeah, it becomes 25, right? So 75 and 3 becomes 25. So 25 times 4 is 100. So x is equal to 100. And I don't put 100 degrees or anything. It wasn't like an angle measurement. It was just a value of the variable, right? Now I need another equation. What do you think, Colin?
1/2 y equals 1.
It doesn't equal 1. 1 isn't a number. 1 is just the angle measure. Yeah.
3/4 times 100 minus 5 plus half of y equals 180.
Okay, I like what he's thinking. Do you guys see this? So he said he could do 1/2 y plus 3/4 x minus 5, and he went ahead and plugged in x was 100. Okay, but Anvita, I think you're seeing what he's saying. Like, when you plug in 100, right here, what should I get for that angle?
7.
I should get 70, right? Because I just found it was equal to 70, right? Do you guys see the markings? So I'm going to go ahead and say that this is 70. And then I'm going to do what Kushal's saying. So he's saying, well, 1/2 y plus 70 equals 180, because those are right next to each other. They make what we call a linear pair. They're supplementary. So this plus this has to equal 180. So when I subtract my 70 over, I get 110. Okay, don't overthink things. I was talking to my calculus class about this today because they were doing like 4 minus 4x equals 0. And I saw them like subtracting the 4 over, dividing by -4. I was like, you are an AP Calc. Like, you should know, looking at that x is equal to 1. Do you guys agree? Like, they should know that. Why are we wasting time, like, subtracting over, dividing? All right, same idea here. So this is what this is saying is half of a number equals 110. half of what number gives me 110? 220, right? So you can think of dividing by 1/2 as the same as multiplying by 2, or you can think about it in that way, right? So y is equal to 220 and x is equal to 100. So then the last question says, well, what's the measure of angle 1? It's not 1 degree. Otherwise, it'd have a little degree mark. What should it be? 70. It's marked with the same markings that the other ones were, right? So it should be 70. And that time we put a degree for that one. Okay, makes sense? All right, so find the values of x and y in the diagram. So we have 109 and x right next to each other. Okay, now if you're marking things up, let's say I draw all my obtuse angles, all have the same markings. So like 109, its vertical angle, its corresponding angle, its alternate exterior angle. All of those are congruent. And then you could go in and you could be like, oh, well, all of these are the same, right? And by doing that, you end up getting a couple equations. We definitely get that x is equal to y plus 7, but is that helping us? No, because I have an equation that has x and y. Okay, I don't want to have equations that have x and y if possible. So Ian, do you see an equation that we can do?
109 plus x equals 180.
Yeah, totally. 109 plus x equals 180. Those are a linear pair. So I get x equals, when I subtract over, 71. So then I know 71 has to equal y plus 7, right? So this was 71 degrees. And that has to be the same as the y plus 7. Oops, I should really do double markings or something. So when I subtract 7 over, I get, what, 64? So 64 is y. So I have x is equal to 71 and y is equal to 64. Okay, do we feel pretty good about that? All right, so let's try these next ones, a little bit harder. Sorry, do you need me to go back?
Yeah.
Okay, so sometimes the parallel lines are within other shapes. So sometimes they're within a triangle or a trapezoid or something. The markings that we have to show that lines are parallel are these little arrows. So see how on that last problem we had little arrows on the lines? That means those lines are parallel. That's when we can start setting things equal to each other. If we don't have the arrows, we can't say that all those like alternate interior are congruent, alternate exterior are congruent. We have to have lines that are parallel. All right, so do we have lines that are parallel? Yeah. So when I was in school, I always had to take like a highlighter or a color pencil, and I had to like extend my parallel lines. I don't know why. I'm a very visual learner. I had to see the parallel lines clearly. And then I drew my transversal in. And I kind of ignored everything else that was in the problem. I'm like, I'm not going to look at this line over here. I'm not going to worry about that right now. I'm only going to look at the red lines. Does this make sense? Do you see the markings that will go on each thing? So we have this one is the same as this one, right? And then we have the other one is not the same as it. But the other one should be supplementary to the ones I just drew, right? So can I get an equation with just x or just y? I can get one with just x, right? What's my equation with just x? Max, do you see it? I see you thinking. Nope. Colin, do you see it?
Is it 3x plus 5 equals y plus 8?
Nope, because that has x and y. So we want x's and, or just x's. Yeah, sure.
3x plus 5 plus 6x minus 14 equals 180.
Yeah, exactly. We want to add this angle, and they're right next to each other. They form a line. They are a linear pair. So that's like our chapter 1 stuff, where we have a line, and we have two angles formed by it. Those two add up to be 180. All right, so we can get x. So we can say 9x minus 9 equals 180. Add the 9 over. So what do we get, 21? 9 goes into 180 20 times. 9 goes into 189 21 times. Okay, so we have what x is. And sometimes it's very useful to us to go ahead and plug in. So if I plug in what x is, then this angle right here is 3 times 21 plus 5, which is 63 plus 5. So that angle is 68 degrees. Do you guys see what I'm saying? This angle right there. Does that help us? Can we find y now? Set up an equation to find y. Cam, you got it?
Yep.
3x plus 5, well, not 3x plus 5 because I already found that, right? It's 68. 68 is equal to y plus 8. What did you get? 60?
Mhm.
Yeah, so x equals 21, y equals 60. Do you guys see what I'm saying? So sometimes you use one equation to solve, to plug back in and find an angle to find the second one, okay, to find the second variable. All right, so this drawing's a little bit different. You got to use your knowledge of all these markings in geometry.
Question.
Yeah.
Why did you do y plus 8 when it's 6? Oh, wait, never mind. I thought you did 6x plus 4, minus 14 instead. Or you were supposed to do
Oh,
this.
yeah.
Never
You
mind.
could do 6x minus 14, and then they would add to be 180, right?
Okay. Sorry.
So either way. All right, so let's look at all of our markings. So what do these mean? Parallel lines, right? So we have parallel lines. So if we need to extend it, you know, like I did when I was in school, you can do that. We can say, okay, here's a transversal. And we have this little square. What's the little square mean? Right angle, so that's 90 degrees, right? Would it be the same as this one? Yeah, would it be the same as this one?
Yeah.
Yeah, so they're all going to be 90 degrees. Do we see why that's true? Because of this first one, this 5x is equal to 90. We end up getting x equals 18. And we know that if we have 90 degrees and we have angles right next to each other forming a linear pair, and one of them's 90, the other one has to be 90. So that means this other 9y is also equal to 90. So we get y is equal to 10. Done. So we're reading these geometry symbols. All right, so the next one is what we call, well, normally we'd call it a parallelogram, but we would actually need that these ones are marked as well. So I don't know if this, I think those are supposed to be marked as well. Let's mark them. I should have put my triangles. You guys see what I'm saying? So go to mark them as parallel. All right, it's a little tricky. Eventually we're going to talk about parallelograms. We're going to learn all the rules for parallelograms. But what do you think, Colin? Do you see an equation?
No, never mind.
No. Okay, so we have our parallel lines cut by a transversal. So that's one way.
Oh, wait.
So we could have like this angle and this angle are not the same, but they're supplementary. But that doesn't really help us, right? It gives us x's and y's. Yeah, do you see something?
Would it be 8x plus 40 plus 6x equals 120?
Yeah, so instead, maybe I should think about these parallel lines first, the ones that were given to us anyway, right? And then we can say, oh, well, all of the acute angles are the same. All of the obtuse angles are the same. But otherwise, they add up to be 180 if you have like the acute and obtuse next to each other, right? So we're going to say 8x plus 40 added to 6x has to equal 180. I guess I didn't really need these other parallel lines, so we can get rid of those other parallel lines. I'll show you why in a sec. So we get 14x plus 40 equals 180. So we have 14x equals 140. So x is equal to 10. So we can go ahead and we can plug in. So if I plug in 10, I get 60 here. And if I plug in 10, I get 8 times 10 is 80 plus 40. I get 120. Does that make sense that I should have 60 and like 120 with it? Yeah, they add up to 180. Okay, so now we're looking at this side. So again, I have parallel lines cut by a transversal. So ignore this left side of our picture. We're only looking here. So what do we know about this angle and this angle here? Are they the same? Are they different? Do they add to be 180? They add to be 180. They're not the same. One's obtuse, one's acute. But they add to be 180. Do we see this picture? So we're going to have 7y plus 3y minus 10 has to equal 180. So I get 10y minus 10 equals 180. So I get 10y equals 190, so I think y is equal to 19. So it's not actually a parallelogram, it's a little bit off. All right, good so far? Okay.
How'd you get 190?
I added the 10 over.
Oh, right.
Mhm. All right, set up the next equation. It's an easy one. Do they add to be 180 or do they equal each other? They equal each other. So I have 3x minus 15 equals 2x plus 7. So when I subtract the 2x over, I get x minus 15 equals 7. So I get x equals 22. Easy? All right, you guys try the last two, so I'll give you a second to try them.
Can you go back real quick, please?
Mhm. Yeah. All right, so this first one, so we have lots of parallel lines, right? So sometimes this is hard when they're kind of all overlapping. So let's look at our first set of parallel lines. So we have the top and the bottom parallel lines, this one and this one. And let's say they're cut by this transversal here. So that means x and 3y would match up, but that's not going to create a nice equation for us. But then these other two angles match up as well. So could we use that somehow? Well, we can say that these consecutive interior angles, yeah, what do you have?
X plus 72 equals 180.
Yeah, they have to be equal to 180. So we get x is equal to 108. So you guys get that for x? All right, so once we have that, well, we can also say that the 72 and the 3y, well, they have to add up to be 180 as well because they're a linear pair, right? So we're using these words because eventually, surprise, surprise, we're going to be doing some proofs with these, right? So we're using all these words. So we subtract the 72 over, we get 3y is equal to 108. Does that make sense that it should be equal to 108? Yeah, because I could have just said, oh, now that I know x is 108, 108 matches up with 3y, right? I could have also done it that way. So when I divide out, I get y equals, did you guys get this? What is that? I should know. So 3 times 9, 18, 36. Did you guys get that for y? All right, so now we're completely ignoring the lines that we've drawn in before. So this is where maybe it helps to draw a second picture. And you're like, okay, I got this 3z plus 18. Well, its parallel lines match it up with x right here, right? Do you see how those are corresponding angles?
Yeah.
And what was x? 108. So we're going to say 108 is equal to 3z plus 18. So when I subtract 18, I get 90. So z should equal 30. And those are our three answers. Does that make sense? Did everybody get those three answers? Okay. So let's try the next one. So again, look for your parallel lines. So we have parallel lines marked. So that's when we take our highlighter or our colored pencil and we mark those in. It helps. And let's go with this first transversal. So you got to kind of ignore that other line. I know it's so hard to ignore that other line. But we have this big angle, this big angle, this big angle, this big angle, right? Do you guys see the four angles there? Those are our obtuse ones. And then we have acute, 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 and acute. So let's look for things that have y. We want an equation with just x, just y, or just z, right? So let's look at y's. We have a y minus 18, and we have a y plus, what does that say, 12? 72? 12? So should those add to be 180, or should they be congruent to each other? That's all we're doing. They add to be 180, right? They're not the same. One's obtuse, one's acute, right? So we're going to say y minus 18 plus y plus 12 equals 180. So I get 2y minus 6 equals 180. So 2y equals 186. So what did you guys get for y? 93? Mm-hmm. All right, and we can use that to help us. So if we know y is 93, then we can plug back in and find other angles, right? So if I have 93 minus 18, what do I get when I do 93 minus 18? 75. Yeah, this is 75. This is like the problems I give my son all the time. He's in 2nd grade. He's working on his mental math skills, so we're always like, 93 minus 18. Well, I'm going to carry 2, and I'm going to, oh, it takes forever. So you guys should work on your mental math skills, though. So 75. So how can we use this to help us? Well, this blue angle is 75. What does x have to be? Well, x is just part of it, isn't it? How about z? Let's go here. I don't know. We got something weird going on, don't we? Do we know anything else? Yeah?
I was going to say for the formula, we can probably do z plus 75 equals 90.
Ah, she's saying z plus 75 equals 90. And how, Maya? Let me draw this. Let me erase so we can identify why this is true. We have our parallel lines. Now we're using this transversal.
Because the one on the right is
Yeah, and that said 90, so this should be 90 as well. So x is equal to 90. Done. And then if this was 75 when we plugged in, 75 plus z has to equal 90 as well. So we end up getting z is equal to 15. Okay, so we have found everything that we needed to find. Does this make sense? All right.